Okay, so this is a really interesting development for AWS, especially for cloud costs. There were two cases of AWS users getting surprise billing entries from S3 usage alone in the last week. Both of these cases can be manipulated to result in a denial of wallet attack, and it turns out just making your S3 bucket private won't even do the trick. Now, denial of wallet attack is a phrase derived from denial of service attacks. Instead of just suffocating your service with a large number of requests, the point about denial of wallet attacks is to increase the cloud expenditure in the workloads that are deployed to these hyperscaler clouds. So hyperscaler clouds are basically major cloud providers like AWS, Microsoft Azure, and Google Cloud. And the basic premise about the cloud is the elasticity. And elasticity makes it easy to create and deploy resources, but on the other hand, it also makes it easy to increase the cloud costs without actually having any control over it. One of these cases is a sort of an amplification of costs based on a relatively small number of requests. It's a really interesting use case. This blog post was written by Ben Lisfeld, published in the company blog for Varvis, which I think used to be Limbus Medtech. Or the other way around, their domain name doesn't really match the branding. But in any case, in this blog post, they describe a scenario where the billed amount for the data transfer out of an S3 bucket for a specific request type can be up to 50 times the actual received amount. Their company is hosting large files on S3 to be publicly accessible, and these files seem to be accessed through byte serving requests. Now, byte serving requests or HTTP range requests are basically asking for a specific byte range of a resource instead of the whole resource. And this is useful for scenarios like streaming content or processing parts of a large file without actually downloading it fully. So let's say if you're training a machine learning model based on a part of a dataset, that could be achieved through a byte serving request. I used to think this was chunk responses, but turns out it's a different type of request and response process. So they first noticed an anomaly in the S3 egress charges. Investigating this, they found a bug in their client code. The client was making a number of range requests and then cancelling them immediately afterwards. But at the same time, the difference between expected charges for this bug and the actual charges seemed to be way higher than even AWS specified estimates. Now, for some background, AWS S3 data transfer charges mention that the billed amount can be over a few gigs from the actual received amount because S3 cannot terminate request immediately. So if the client actually cancels a request immediately after making it, there's going to be some time elapsed before the request can be fully terminated. The numbers mentioned here are 3 gigabytes actual over 2 gigabytes expected. So it's about 1 or 2 gigabytes of difference in billing that AWS says that can be expected. However, for Ben and the team, the difference wasn't a simple gig. It was actually 127 terabytes. They received 3 terabytes of data and they got charged for 130 terabytes of egress. And they got a 13,000 USD bill instead of the expected 300 USD bill. Try explaining that to your manager, and then to your financial controller, and then to people and culture officer.
Oh, I've left one. Stay there. Shoot her before him, but make sure he sees it. Or in this one, kill him, take him to his church, dump him in the pulpit. And I'll leave the rest up to you.
And then, finally, to your next interview. They mentioned that this behavior was observed under a set of conditions. The requests were made for large files, generally larger than 1 gigabyte, and the requests were range requests that got immediately cancelled. So it looks like instead of an arbitrary amount of overflow, S3 charged for the full requested byte range, even if only a fraction of that range was delivered. And this isn't even a single occurrence for a single bucket. They have observed the same behavior for several buckets for several weeks. And it doesn't have to be a public bucket either. This can be reproduced for a pre-signed URL pattern as well. The other case is even more interesting. This blog post is written by Marche Pokvies, and I'm sorry if I pronounced your name incorrectly. And his case is a series of unfortunate events. He created an S3 bucket for a test and ended up almost having to foot the bill for $1,300 USD instead of his expectation of being under the free tier usage. How? Well, the name he used for the bucket had been the default placeholder value used for S3 based backups in some popular open source tool he doesn't want to disclose at the moment, and possibly hundreds or thousands of deployments of this tool had not changed the value and had been trying to backup configuration into this bucket up to this point. The moment he created the bucket, even sticking to the best practice of keeping it private, what he did was to promote those responses from being 404s to being 403s. And the thing about unauthorized requests is that the bucket owner still has to foot the bill for that. Worst, if the client actually didn't specify a region in the request for that bucket, it first ends up in US East 1 and then leaps to the correct region. And when that happens, there's another additional charge for the bucket owner. Funny thing is, he managed to collect some of those backups over 10 gigabyte of data by opening up the bucket for just 30 seconds. And when he reached out to some of those companies, no one really replied back. They're probably busy counting those beans, I guess.
Well, then I just have to ask, why couldn't the customers just take them directly to the software people, huh?
Anyways, this is a case of getting DDoSed, but not having control over the server to block any of those clients. You don't really control how S3 API is throttled. You can't manage any configuration in the actual server that hosts the S3 API. Looks like AWS has been onto this. On Twitter, Jeff Barr has a tweet that acknowledges the situation and says, "We agree that customers should not have to pay for unauthorized requests that they did not initiate. We'll have more to share on exactly how we'll help prevent these charges shortly." This is reasonable. There are some opinions that say even unauthenticated requests have an impact on AWS that will have to be charged back. But the opposite side of that argument is, even if that's true, it shouldn't be charged on the same scale as a standard put request. At least we got a response from a higher up in AWS, so that's good. Now, what are the lessons here? First, it's obvious we as cloud users have very little control over blocking requests before they hit the bucket. We don't have any control over how S3 API throttles those requests. Both of these scenarios, if executed, will leave us just looking at the dashboard, hoping for the best. So the alternative here is to have that reactive capability to understand when something like this is happening and reduce the impact. The two key AWS services to use here are cost anomaly detection and AWS budgets. Cost anomaly detection will trigger notifications when unexpected spending patterns are detected. And with AWS budgets, an alarm can be created specifically for a service, in this case for S3 usage. Another possible workaround is to keep the S3 bucket names secret, at least until AWS provides a way around getting DDoSed in the wallet with no control. We just have to add the S3 bucket name to the list of strings that should not be exposed. Obviously, keep your buckets private. Yes, there is a config to make it open, but probably a thin layer of an API before the actual bucket could introduce a point of control for potential out of control requests. I know it's the age of AI or whatever, but throttling at the API isn't that old of a technique. And last, get your cloud financial management sorted out. This is important. Observability into cloud costs is key, so there is a basic layer of easy work that can be done to get that up and running. Use tagging, enforce it, and based on those, use Cost Explorer, AWS budgets, and cost anomaly detection. You'll get a better understanding about when things start to cost more without the graph on Cost Explorer being just a black box. Right, that's it for me. Thank you so much for watching. I'll see you next week.